Well, welcome everybody to today's Zoom call. I'm Justine Lobello. I'm the marketing manager here at Bluebird, and joining me today are three experts in the EV field. We have Albert Burley, who is Bluebird's person that's over electric bus sales. So he's going to be going over a few things with you. Following that will be Mark Trahan with Nuvve, and then Joseph Gottlieb with Rhombus. And we're going to talk about vehicle to grid solutions today. Just like all the other calls, this is being streamed live on Facebook as well. If you have any questions, feel free to send a chat to the host, which is myself, and I'll be sure to ask the panelists when we get to the Q&A section. And if you have any questions on Facebook, just make a comment, and those questions will be given to me throughout the presentation as well. And we will go ahead and get started. So Albert, I'm going to go ahead and unmute you, and then you can begin.
Great. Thank you, Justine, and good morning, everyone. I'm Albert Burley with Bluebird Corporation. Thank you for joining us today, and as we discuss Bluebird electric school buses and V2G technology. Next slide. Here's a look at our agenda for today. First, I'll review Bluebird's history with electric school buses and where we are today. We'll discuss growth in electric school buses and the benefits of EVs that are driving this growth. Then we'll get into the meat of the presentation, which is vehicle to grid, and provide you with a roadmap to V2G implementation. And then we'll have plenty of time at the end for some Q&A. Next slide. First, some background on Bluebird's introduction of electric school buses. Although our current iteration of electric school buses started only a couple of years ago, we were the first OEM to introduce an electric school bus back in 1992. Back then, we collaborated with Westinghouse Electronic Systems in the development of that product. We sold about 30 of these buses over the next several years, but it was certainly before its time and had some limitations with things like range and weight and what have you. So we didn't continue that product after about the year 2000. Next slide. So where are we today? Well, in 2016, Bluebird received a $4.9 million grant from the U.S. Department of Energy for development and commercialization of high-powered V2G school buses. In 2017, we launched our current iteration of the Bluebird electric bus at the STN Expo in Reno, Nevada. And in 2018, we delivered our first electric school buses to customers in California. And jumping ahead to 2020, today we're the only manufacturer to have produced and deployed electric school buses in Type A, Type C, and Type D. We're also the only manufacturer to offer standard CCS1 connector to allow for either AC level 2 charging or DC fast charging. And in addition, we are the only manufacturer to have V2G capability now standard on all of our electric school buses. Next slide. So where have we sold and deployed our electric school buses? You can see from this map that the blue states are where we've sold electric buses. The majority have been in California, but we've sold buses in 13 other states as well. And you can see we sold buses in cold weather climates like New York and North Dakota, and warm weather states like Arizona and Texas. We actually even have an electric school bus in the state of Hawaii operating right now as well. And if you look at the chart on the right, it shows our sales each year since introduction back in 2018. And as you can see, we've experienced significant growth each year, and we currently have sold about 200 buses in 2020. And in total, we've sold about 300 electric buses since our introduction, and we're expecting some more significant growth in 2021 as well. Next slide. So what's fueling all this interest and growth in electric school buses? Well, really for several reasons. And first and foremost, it's due to zero emissions and the significant benefit it offers cleaner air for our kids. Replacing one diesel bus can reduce greenhouse gas emissions by 54,000 pounds each year, and that's the equivalent of 3.7 pounds of carbon dioxide for every mile driven. Kind of to put this in perspective, the air quality inside an electric bus is actually 6 times cleaner than inside a diesel bus. Also reduce maintenance costs, really fewer components and less maintenance required on those components result in about an 80% reduction in maintenance costs from a internal combustion engine school bus. Quiet operation, these buses are very quiet, resulting in really less sound pollution in neighborhoods and safer operation for the driver. They're actually so quiet that the bus comes standard with a noise generator that is enabled at speeds less than 20 miles per hour. Grant funding, certainly a big driver in the growth of electric school buses. For example, through June of this year, almost $50 million has been awarded through VW funding towards electric school buses. Outstanding performance is another big benefit. These buses have exceptional acceleration compared to a traditional bus. And last but certainly not least, vehicle to grid technology. We'll talk more about this, but this is the opportunity to generate revenue to create a positive total cost of ownership equation for these buses. Next slide. So moving on to more information on V2G, as I mentioned earlier, we developed a roadmap to help customers navigate the steps to V2G implementation. Next slide. And the first step to select, the first step in the roadmap is to select a V2G compatible bus. So first, choose a bus with sufficient large battery capacity. Our Bluebird electric bus comes with 155 kilowatt hours battery, which certainly meets this requirement. Second, the bus must include the charging hardware that enables bidirectional energy flow. This means the bus must be included with a DC fast charging capability, and it should have sufficient charge rate. All Bluebird electric buses have DC fast charging capability with a maximum 60 kilowatts per hour charge rate. But it's also important that the bus allows for AC level 2 charging as well. At times, the bus may need an opportunity to charge while at a facility equipped with only level 2 charging. Bluebird electric buses are equipped with a CCS1 connector, which allows for either level 2 or level 3 DC fast charging. Also a critical element is to choose a bus with an OEM integrated, robust, and proving V2G communication protocol. Like the charging hardware, the bus must be equipped with the software that allows the bus to be V2G enabled. Bluebird has worked with Nuvve to develop the V2G communication protocol, which is required for V2G implementation. And lastly, choose a bus with a V2G partner that can aggregate across a multi-bus fleet. And really to tell you more about V2G and why aggregation is critical, I'll now turn it over to Mark Trahan from Nuvve. Thank you.
Thank you, Albert. So hello, everyone. I think one of the important messages you just heard from Albert is that the bus is already enabled for vehicle to grid. And that's one of the great things about the Bluebird buses is that they're already compatible and can have bidirectional flow. And I'll explain a little bit more what all that means. Vehicle to grid was really invented several years back, about 20 years back, actually, to help include renewable energy onto the grid and help buffer fluctuations you might have from wind or solar, where energy is not always there, and there are moments where we need it and we need to store it. And the great thing about the Bluebird buses is that you have a big battery on board and you have a big power capacity connected to it, which Joseph will talk about afterwards on the charger side. So just seeing if you just go to the next slide. Just a few words about Nuvve. We've been doing vehicle to grid for a while. We originally invented this concept, our founders did in 1996. For the past 10 years, Nuvve has been deploying vehicle to grid around the world in very different locations, from Japan, where we're working closely with grid operators there, to Europe, where we have now one of the longest operating fleet in vehicle to grid for 4 years in a row now. We've been doing every day, day in, day out, V2G. We have also setups in France, in the UK, Spain, Portugal. So we have more and more operations, which we're gaining more and more knowledge about vehicle to grid. And in the US, we have now several setups. Some have been experimental. And the good thing now is that with standard vehicles available, vehicle to grid is entering this new phase of rolling out with school districts these large buses. Let's go to this next slide, Justine. I want to explain a bit more how this works. So what did Albert mean when he said bidirectional? It means that we're using a battery inside the bus as a real battery. The energy goes in and out of the battery. and it is controlled so that we can anytime control the charge rate and the discharge rate of this battery according to different factors that might be local or might be at the grid level. One thing that's very important to understand with vehicle to grid is the driver is always protected in his number one task, which is driving. So we always ensure the driver has enough energy to drive and will never show up to his vehicle with an empty battery. That is the rule number one of all our algorithms. I'll explain on the second slide, please, Justine, the benefit of the aggregation. Once you control one battery, our software platform controls all the batteries in the vicinity or in the wider state that can be controlled. These batteries on our side can be inside a vehicle or inside a building. But the important thing is to create a virtual power plant. With that virtual power plant, we can then deliver services to different elements of the electric grid. That might be at the building level, where we might optimize, for example, the energy usage at a school. That school might have solar panels, might not, but we can use the batteries of the vehicles for that. We can use this virtual battery as well to give services to the electric utility or to the electric system operator. And by doing that, we manage to generate value. And that value we share with customers, which is on the next slide, please. That value can be created at two different levels. We can make savings at the building level, and this is optimizing the energy use for the local school district. And those savings, of course, are retained by the school district. And we can also make revenues from energy markets. Now, there are lots of different energy markets, and those energy markets, you and I as individuals or as a company, we can't access them because you need a bigger power plant to access those. So by doing an aggregation, we're able to get revenues from energy markets that we then share with our customers. And by having that revenue coming from vehicle to grid, it enables us to lower the cost of ownership of electric school buses and be more and more competitive towards diesel prices. We believe that in the future, we will be at parity or below, as the cost of batteries will also come down in the future. Now, how does, next slide, please, Justine. On the parking lot side, there are a lot of benefits here with school buses because they are parked a long time and we're able to throttle them as soon as they're plugged in. Our software automatically takes over. And whatever the weather, whether it's hot weather as these buses in California or cold weather as these cars here sitting in Denmark, vehicle to grid doesn't affect the performance of the battery. We're able to throttle these, and there are even some circumstances where we might improve the battery life of the battery by throttling it during long periods of standby time. Next slide, please. One of the big problems of school bus depots is that they can be very large. And another difficulty with electrifying them is making sure you bring enough power to these school depots. What vehicle to grid can do is also help you share that energy, make sure all your buses are loaded with the energy they need, and optimizing the connection size as well at the transformer level. Next slide, please. Now, how do we do this? We do this by a management platform that uses mobile applications, that uses dashboards that we provide to customers. A fleet manager can at any time view his whole fleet and understand where the charge levels is of the whole fleet. Drivers can interact directly with their battery. They can put it in charge mode if a new trip has been forgotten. They can schedule, for example, trips as well. So there's a whole suite of software that helps users manage the battery. Next slide, please. And of course, we provide maintenance and support, which is important. It's very important that we're often the first ones to know if there's a problem with your bus or if a driver forgot to connect it because of the dashboard. So we can easily interact there with the fleet manager, or if we need to send a technician on site. And at the same time, we'll also support customers in installation. So I hope this gives you a good overview of vehicle to grid then. I'll pass it over to Joseph to explain an also important side, which is the charges.
Thank you, Mark. Right, so next slide, please. We're Rhombus Energy Solutions. And thank you. And we're a made in the USA power conversion company. Our specialty is bidirectional high-powered inverters for renewables, energy storage, and microgrids. We're originally a power electronics company that started making chargers, not a charger company learning how to make power electronics. So we have a very large leap ahead into the V2G charging space. Our products are UL 1741SA certified, which also includes California Rule 21 and HECO. We are headquartered in San Diego. Our manufacturing facility and high power testing lab is in Dearborn, Michigan. So everything is made in the USA, which is great for a lot of our partners. And our products are easily customizable depending on OEM and fleet applications. We've deployed many systems worldwide. Again, a lot in the energy storage and V2G space before the charging space as well. Next slide, please. Why V2G is compelling? Energy storage and stationary energy storage. And what I mean by that is when they're not being driven around. So for example, a typical electric vehicle with an 85 kilowatt hour battery pack can power just a single home for 3 days of use. An EV school bus with a larger battery pack can take on 5 or more, and then a transit bus can take on 23 days of power consumed by a US home. So that is money in the bank in terms of energy when they're sitting there not being deployed. Next slide, please. One of the requirements for the V2G charging infrastructure is that you have the smart capabilities. Your PCS or power converter or charger is the gateway to the utility, which is kind of the difficult part because there are a lot of requirements that are involved. There's a lot of certification standards from UL, from IEEE, from SAE, and from ISO. And so, making sure that you've got the balance and your equipment can handle all of those standards for future-proof is pretty critical. You have multiple communication paths. You have the communication between the vehicle and the charger, between the charger and the grid, between the charger and the aggregator, like Nuvve, and so on. So each one of those is pretty critical in the functionality of these systems. Some of the other requirements are having enough capacity to charge the vehicle in a short amount of time. Industrial rated, obviously these vehicles, when they need to be used, have to be used, and it's very critical that this equipment has no downtime. So, our equipment is fully capable to run continuously, day, night, all the time, 100%. We also, our equipment is easily maintained and serviceable if any kind of problems occur. That's another great requirement to have. If you've got a piece of charging, a charger, and the only way to fix it is to remove and replace the entire charger, that's probably not the best option for you. The other is remote diagnostics and prognostics, so that you can reduce those downtimes, see any issues before they occur, and get a service person in there quickly as possible to get those items taken care of. Next slide, please. So for school buses, it's a very, very intriguing opportunity. I know the slide before that Mark had showed a field full of school buses just parked. And unfortunately, this wasn't deployed earlier because this is the absolute perfect time. There's those energy resources just sitting out there in the parking lot, not driving kids around, and can be making the utility, the school districts, I apologize, money. Again, we say money in the bank, and those, just sitting there doing it. So our guidelines is, you want something in terms of right now, we recommend one PCS to one dispenser. The multi-dispenser system is interesting. It's a way to reduce costs. However, it impacts the V2G operation. So you have to carefully consider that when you go forward, because each one of those vehicles that's plugged in at that time can be used for its energy resource. And so we right now say the optimum ratio is about 1-to-1. The PCS should also be sized to fully charge buses in under 6 hours. We recommend the 60 kilowatt size. As Albert had said, that's kind of the maximum their system is designed for right now. And so we think that's a great opportunity. You can charge a single bus in 2.5 hours if it's got, a 150 kilowatt hour pack. Next slide, please. I think that's it. Yeah, very good. So I will pass it back to the host.
Hey. Well, thank you all very much. And we do actually have a couple of questions already. Albert, I'm asking you to unmute as well so that in case you want to take any of these questions, you can. The first question I got was, can you define DC fast charging? So someone just wants a more clear definition of that.
Well, from our perspective, DC fast charging is when you are using a charger that produces DC instead of the AC onboard charging system. And, again, it depends on how you classify it and ask, but, we believe anything over 30 kilowatt, we consider very, fast charging or rapid charging.
And I'd also add, just for a reference point, our bus can do both level 2 or level 3 DC fast charging. A level 2 will take you about 8 hours if the battery is completely depleted to get it to a full charge. And with the DC fast charging, as we mentioned earlier, about 3 hours is what it would take to charge that bus from 0 to 100% charge rate.
And currently our bus is the only one that has the capability to do both with the CC-S1 charger or connector, I should say.
Right, we do offer that as standard, correct.
Good. The next question I got is, knowing there will be battery replacement costs for the vehicle, what, if any, are the future replacement or upkeep costs for V2G?
So interesting question. Real quick, from the power supply and charger perspective, there's not much difference to us in terms of maintenance fees and reliability and repairability of these units, whether it's unidirectional, bidirectional. We have the same good quality, long life systems. So it's really more of a question on the battery pack side and whether or not it's a good thing or a bad thing.
I'd just like to add for the V2G side, I mean, we know that from what degrades a battery over time is actually the age of the battery, then it's how you drive the bus, in terms of acceleration, regenerative braking, fast charging can affect a little bit battery life, and vehicle to grid is very minimal as well. So we don't expect that vehicle to grid is going to change anything on the lifetime of your battery compared to a regular use of the bus here. So it is going to depend if how the bus is used as well and how many miles it's driven.
Next question I got is, how do the economics change when adding V2G to your fleet?
A lot. Vehicle, but it is going to depend where you are and what markets we can access from different states, different geographies, different utilities. But it really is going to help reduce the cost of ownership of an electric vehicle. We have customers in certain locations that maybe have the energy for free, basically, for driving. There's different ways of doing it, but a lot of the time when you're using V2G, you're going to get the subsidized cost of charger, of installations. We're going to try to put some of those revenues of V2G up front to help the school districts make those decisions around vehicle to grid, so that it becomes apparent at the purchase level.
Good. And actually, the next question is, someone's asking if we have any, or perhaps Nuvve or Rhombus does have some resources or white papers that show revenue generation from V2G that's currently in use. Any projections? I know that we can actually
Right.
help run some projections, Albert, if I'm not mistaken, when someone's considering an electric bus. But the pretty good question there.
Yeah, and those revenues are going to change depending on your location, on your electricity rates, on the electric markets you can reach. So we're already accessing energy markets in California, in the eastern United States with PJM, where we're accessing different markets. Some are more demand response type markets, others are frequency regulation markets. I don't want to get too much into the detail, the technicality of the energy markets, they're complex, and that's what we do. But the revenues can be substantial when you have a big battery like you have in the Bluebird bus with a big power connection thanks to the charger from Rhombus. So those revenues then accumulate. We accumulate them over time, over the lifetime of the bus, and they can be, put into the finance up front, into the purchasing cost.
So Albert, can you speak to that roadmap and leading a customer through the process?
Yeah, absolutely. So, I mean, I think what's important is you can look at certainly a TCO calculator as well, because there's a lot of other variables besides just the V2G revenue. As we spoke to, the maintenance costs are pretty substantial when looking at electric bus versus a diesel bus, for example. So we can walk a customer through that so they can understand really what the total savings would be over time. And we can also assist in locating any potential grant funds that may be available. As you mentioned, still a lot of VW money available out there, and there's some other potential grants that could help offset quite a bit of that. So that's certainly part of what we do when we try to help a customer implement electric buses into their fleet.
And I think that's important. We definitely would encourage school districts to get in touch with the Bluebird representative or dealer, so that we can then work with them in providing the best offer that makes sense in their location.
Yeah.
Cool. Well, we've actually kind of gotten to the end of our presentation. So thanks everyone for your questions. If you have any other questions or want to reach out to us, the contact information is up here. We have recorded this video. It will be posted on YouTube and our Facebook page, and we will email all of the participants after the call with a copy of the video so you can watch it at your leisure at a later time. But thank you very much, Albert and Joseph and Mark, for your time, and great presentation.
You're welcome. Thank you, everyone.
Thank you, everyone.
Thank you very much. Have a great day.
Thank you. Bye-bye.